Okay, pause, copy, try, pause, copy, try. Okay, I'll go through this one. Now we say, like before, we say let A inverse equal x, y, z, w. So A inverse, let's skip that line there. A times A inverse, so B 0 C D x y z w is equal to I 0 0. All right. So a little bit different this time. The 0 has migrated from bottom left to top right. Still get 4 equations here. Bx is I. By is 0 matrix. Cx plus dz is 0. And cy plus dw is an identity matrix. Okay, I didn't notice this in my previous example, but I'm noticing now that from this equation, I can immediately conclude that B must be invertible. Well, you have to, first of all, deduce that B must be square. But anyway, so B is square, X is square, I is square. So the invertible matrix theorem tells me that given this equation, I know that B is invertible. So B is invertible, so I can solve for X here. And I can solve for 0, or solve for Y here. Then similarly down here, I got my X, I plug in C B inverse plus dz is 0. So I get CB. Why don't I just leave the dz on the left? dz is equal to negative C B inverse, and then D is equal to D is equal to nope. Z is equal to D inverse, appearing on the left of the final expression there. Okay, because you had to multiply. You need to stick a D inverse here. So that means you have to put a D inverse right there. The D inverse cannot appear over here. That is not the way it works. Y is 0, so I get dw is I, so w is D inverse. Okay, finally, write down my answer. A inverse is x, y, z, w. B inverse y is 0. Z is this thingamajig. Oh, it's awful. Put the 0 a bit further to the right. X, Y, Z, W, D inverse. Okay, so there you have it. Okay, I'll remind you again, I was able to deduce that B must be invertible. Okay, from here. Okay, you have to first deduce that X and B are both square. And then the invertible matrix theorem tells you that both B and X are invertible. And then what about D? Why is D invertible? Well, B is invertible, which allows me to conclude that y is 0. And then I plug that y equals 0 here, giving me this equation here. Okay, I see that, well, I prove that D and W must be square. So the invertible matrix tells me that, given this equation, these two matrices must be invertible. So D is invertible as well. Okay, and all I needed to assume at the beginning was that A is invertible.